Then you can express it as a sum of three partial fractions: a by x minus a, b by x minus b, c by x minus c. A divided by x minus 4 plus b divided by x minus 2. Take this as equation 1. So substitute the value of a and b in equation 1. Whenever you have a quadratic equation in the denominator, just split into two linear factors. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So in our previous session, we have learnt about the rational fractions and how to write any improper rational fraction as a sum of polynomial and proper rational fraction. So what do you mean by rational function or rational fraction? That is any function of the form f of x by g of x and g of x is not equal to 0. So the condition is the denominator is not equal to 0, where both f of x and g of x are polynomials of degree n is called as rational function or rational fraction. And also we have learned the types proper and improper. That is, whenever the degree of f of x is less than the degree of g of x, then it is called as proper rational function. And suppose the degree of f of x is greater than or equal to degree of g of x, then it is called as improper rational function or rational fractions. Also, we have learned how to write an improper rational fraction as a sum of polynomial and proper rational function. So that is, improper rational fraction can be expressed as a sum of polynomial plus proper rational fraction. So now the process of resolving these rational function into simple fraction is nothing but resolving into partial fraction. So before going to resolving any rational function, we have to know about some different cases or types about the numerator and denominator. In this session, we'll learn how to resolve a rational function, that is resolving partial fraction. Next, so here we have different cases for resolving partial fraction. So type 1. So non-repeated linear factors. Denominator contains non-repeated linear factors. Then how you can express a rational function as a sum of partial fraction when you have non-repeated linear factors. Linear factors are nothing but linear polynomials. So here we have two different linear factors, that is x minus a, x minus b. Here you have a numerator polynomial which is also linear. Whenever you come across these type of f of x and g of x, so then this can be written or resolved in this form, that is a divided by x minus a plus b divided by x minus b. Same case, suppose you have a quadratic polynomial in the numerator and three different linear factors. Then you can express it as a sum of three partial fractions: a by x minus a, b by x minus b, c by x minus c, where the constant a, b, c can be solved by solving the equations in the same rational fractions. Suppose you have repeated linear factors. whenever a factor is repeated. For example, x minus 2 whole square. Here you can consider the case of x minus 1, x minus 2, x minus 1, x minus 2, x minus 3. All three are different linear factors. Suppose you come across a factor where it is repeated. That is, you can see here x minus a whole square. That means x minus a is repeated 2 times. So whenever you come across these type of rational function, then you have to split them in terms of 2 linear partial fraction, that is a divided by x minus a plus b divided by x minus a whole square. The same condition for binomial, the same condition for, suppose if you have a quadratic polynomial in the numerator and whenever you have a repeated linear factor, then the factor which is repeated can be written as a by x minus a, b by x minus a whole square. And one more linear factor you have which is not repeated, then take that as a sum of one more, that is c by x minus b. Next we come across the last one, that is non-repeated factors. Here I have not mentioned whether it is linear or quadratic. Suppose you have a polynomial in the numerator which is quadratic or a linear, and you have a factors like this. One is linear here and another one is quadratic. So linear means degree 1, quadratic means degree 2 polynomial. Then you can write this as a divided by x minus a, and this quadratic polynomial can be written as bx plus c divided by x square plus bx plus c. Here capital A, capital B are different from small a, small b, small c. All may have different values. So these are the different cases you should remember when you are going to resolve any rational functions. We'll take few problems. How to resolve a rational fraction. Before resolving any partial fraction, you should go through these cases. Here I have taken an example, x plus 2 by x plus 4 into x plus 3. So this is of the form px plus q by x minus a, x minus b. Whenever you have non-repeated linear factors, then you can write it as a partial function a by x minus a plus b by x minus b. So I'll write it as a divided by x plus 4 plus b divided by x plus 3. So I'll take this as equation 1. Next I'll take the LCM and I'll equate the numerator. So what happens? I'll get x plus 2 is equal to a into x plus 3 plus b into x plus 4. Since the denominator are same, we can write the numerator. So I'll take this as equation 2. The next step is I have to find the value of a and value of b. For that, what I'll do, I'll see the terms which is with a and terms which is with b. So what happens for a when the value of x? So to find b, I'll make a as 0, and to find a, I'll make b as 0. How it is possible? Just by substituting the value of x in a and in b. So I'll take, we have a linear factor x plus 3 here. So x plus 3, if I put as 0, then x is equal to minus 3. So what I'll do, put x is equal to minus 3 in equation 2. If I put x is equal to minus 3 in equation 2, what happens? Minus 3 plus 2 a into minus 3 plus 3 plus b into minus 3 plus 4. Minus 3 plus 3 get cancels. A becomes 0. Here I'll get minus 1. Here I'll get 1b, which is b. So therefore, what is the value of b? Minus 1. In the same way, we have one more linear factor, that is x plus 4. So if I equate x plus 4 to 0, what I'll get? X is equal to minus 4. I'll substitute x is equal to minus 4 in equation 2. So what happens? I'll get put x is equal to minus 4 in equation 2. So what happens? I'll get minus 4 plus 2 is equal to a into minus 4 plus 3 plus b into minus 4 plus 4. Minus 4 plus 4 get cancels. So here I'll get minus 2 is equal to minus a, because minus 4 plus 3 is minus 1. Minus 1 into a is minus a. So when you cancel minus on both sides, you will get a is equal to 2. Now you got the value of a as well as value of b. Just substitute in equation 1. So therefore, x plus 2 by x plus 4 into x plus 3 is resolved as, what is the value of a? 2 divided by x plus 4, and value of b is minus 1. When you substitute it, it becomes minus 1 divided by x plus 3. So this is how we have resolved a rational function as a sum of two simple partial fractions. So these type of question carries 5 marks in your examination. So partial fraction is compulsory 5 marks question in your examination. Next problem, 7x minus 1 by 1 minus 2x, 1 minus 3x. So you have two different linear factors here. So you can write this in the form a divided by 1 minus 2x plus b divided by 1 minus 3x. Now, LHS on both sides. So we can equate the numerator. So when you write this, you will get as 7x minus 1 a into 1 minus 3x. Just cross multiply, you can write the factors, plus b into 1 minus 2x. And when you multiply this, the denominator is same on both sides. So you can live and equate only the numerator. So this, I'll take this as equation 1. This I'll take it as equation 2. What is my next step? To find a and b. To find a and b, what I'll do? I'll equate these two linear factors for 0. So let me take 1 minus 2x as 0. I'll get minus 2x is equal to minus 1, x is equal to 1 by 2. So substitute or put x is equal to 1 by 2 in equation 2. Then what we will get? 7 into 1 by 2 minus 1, a into 1 minus 3 into 1 by 2 plus b into 1 minus 2 into 1 by 2. You can see here 2 and 2 get cancelled. Then it is 1 minus 1. This whole term will become 0. So what I left with here, 7 by 2 minus 1 is equal to, here it is 3 by 2, a into 1 minus 3 by 2. So when you solve this, you will get this as 5 by 2 is equal to minus a divided by 2. So you can cancel the denominator. So therefore, you will get a is equal to minus 5. Similarly, we have one more linear factor. Let me equate it to 0. So what I'll get? Minus 3x is equal to minus 1. So therefore, x is equal to 1 by 3 I'll get. So now put x is equal to 1 by 3 in equation 2. Again what I'll get? 7 into 1 by 3 minus 1 is equal to, so a 1 minus 3 into 1 by 3 plus b 1 minus 2 into 1 by 3. So when you multiply and solve, you will get this as 4 divided by 3. Here 3 get cancelled, 1 minus 1 0, 0 into a is 0. So you can leave this term. Here it is 2 by 3, which becomes 3 minus 2 by 3, which is b divided by 3. So 3 get cancels. So therefore, the value of b is 4. So now substitute the value of b as well as a in equation 1. So therefore, 7x minus 1 divided by 1 minus 2x into 1 minus 3x can be written as, the value of a is minus 5. So minus 5 divided by 1 minus 2x plus 4 divided by 1 minus 3x. So we have resolved it into partial fraction. We'll check one more problem. X plus 8 by 2x square minus 1. Whenever you have a quadratic equation in the denominator, just split into two linear factors. So 2x square minus x minus 1 can be written as 2x square minus 2x plus x minus 1. So 2x common factor, so you will get x minus 1 plus 1 common factor, x minus 1. So you have 2x plus 1 and x minus 1. So quadratic into linear factors. So this can be written as x plus 8 divided by 2x plus 1 into x minus 1. Now you have this in the form of x minus a, x minus b. How you can resolve it? As a sum of two partial fractions, 2x plus 1 plus b by x minus 1. So directly I'll equate the numerator. X plus 8 is equal to a into x minus 1 plus b into 2x plus 1. So take this as equation 1, take this as equation 2. So to find value of a and b, equate the linear factors to 0. So let me equate the first one, 2x plus 1 equal to 0. I'll get x is equal to minus half. Put x is equal to minus half in equation 2. So put x is equal to minus half in 2. What happens? Here it is minus half plus 8. So a into minus half minus 1 plus b 2 into minus half plus 1. 2 to minus 1 plus 1 get cancelled. The term containing b will become 0. Here what happens? Here it is minus 15 by 2 is equal to minus 3 by 2 a. So 2 and 2 get cancels, minus get cancels, 3 ones are, 3 5s are. So therefore what is the value of a? A is equal to 5. So equating the first linear factor, we will get the value of a. We are left with one more linear factor, which is x minus 1. So we will get x is equal to 1. So now put x is equal to 1 here in equation 2. What happens if I put x is equal to 1? So here we have 1 plus 8 is equal to a into 1 minus 1 plus b into, if you put x is equal to 1, then it is 2 into 1, 2 plus 1. So minus 1 plus 1 get cancelled. The whole term containing a becomes 0. We will get 9 is equal to 3b. So therefore, b is equal to 3. Now we know the value of a as well as b. Just substitute in equation 1. So therefore, x plus 8 divided by 2x square minus x minus 1 can be written as 5 divided by 2x plus 1 plus 3 divided by x minus 1. Next question, x by x, x minus 2, x plus 4. So here you have 3 linear factors. So whenever you have 3 linear factors, you can write as 3 partial sums. So the same way here, I'll write this as A divided by X, B divided by X minus 2 plus C divided by X plus 4. So now we will write, I'll just equate the denominator, take the LCM and equate the numerator. So I'll get X is equal to, so A X minus 2 X plus 4 plus B X into X plus 4 plus C X into X minus 2. So take this as equation 1 and this as equation 2. So now, how to find the value of A, B, C? Just equate all the linear factors to 0. Let me take first one, X is equal to 0. So put X is equal to 0 into, put X is equal to 0 in equation 2. What we will get? X is 0. Here if you put 0, it is 0 minus 2, 0 plus 4, 4. Next, plus B, it is 0, 0 plus 4, 4. C, 0, 0 minus 2, minus 2. This complete term will become 0. Because 0 into B into 4 is 0, C 0, minus 2 is also 0. Here we have 0 is equal to minus 8A. So therefore, the value of A is 0. Next linear factor, X minus 2 is equal to 0. That implies X is equal to 2. So put X is equal to 2 here. So put X is equal to 2 in equation 2. If you put X is equal to 2, here this is the equation you have. If you put X is equal to 2, here 2 minus 2 is 0. 0 into any term here is 0. So the first one is 0. Next, here you have 2. B 2, 2 plus 4 plus C, if you put 2 here, 2 minus 2 becomes 0. So 0 into C into X is also 0. So you are left with 2 is equal to, this is 6 to 12B. So this implies B is equal to 2 by 12. So that is B is equal to 1 divided by 6. Next, one more linear factor we have, X plus 4 is equal to 0. If you put X is equal to minus 4 in equation 2, what happens? Put X is equal to minus 4 in equation 2. So if you put X is equal to minus 4, the term A get cancelled because minus 4 plus 4 becomes 0. The term B also get cancelled. You have X plus 4 there. So we have taken X plus 4 as 0. If you put X plus 4 as 0, 0 into X into B becomes 0. So here you have X. So you are left with C into minus 4, minus 4, minus 2. So here you have minus 4 is equal to C minus 4, minus 4, minus 2 is minus 6. Minus 6 into minus 4 is 24. So you will get 24. This implies C is equal to minus 1 divided by 6. So now you got the value of A, B, C. Substitute in 1. So therefore, X divided by X into X minus 2, X plus 4 can be written as, what is the value of A? It is 0. So 0 by X is 0 again. So only B is left. So we will write B as 1 divided by 6 and the factor there is X minus 2 plus C is minus 1 by 6 and the factor is X plus 4. Or you can write this as X divided by X into X minus 2, X plus 4. You can write 6 in the denominator. So this is 1 divided by 6 into X minus 2 minus 1 divided by 6 into X plus 4. 3x plus 1 by x square minus 6 plus 8. So I said if you have any quadratic, then split them into linear factor. So let me split this x square minus 6x plus 8. This can be written as x square minus 4x minus 2x plus 8. So this is, you take x as a common factor and here 2 as a common factor, and you will get x minus 4, x minus 2. So the concept of splitting the middle term. So the same thing here. So this can be written as 3x plus 1 divided by, the quadratic equation is converted into two linear factors, that is x minus 4 and x minus 2. Now you have two different linear factors. When you have two different linear factors, you can write them as a divided by x minus 4 plus b divided by x minus 2. Take this as equation 1. So now take LCM on your right hand side and equate the numerator. So you will get 3x plus 1 a into x minus 2 plus b into x minus 4. Take it as equation 2. So you have two linear factors, that is x minus 4 and x minus 2. Equate them to 0. In the first case, you should put x is equal to 4. In the second case, you should put x is equal to 2. So put x is equal to 4 in equation 2. So now if you put x is equal to 4 here, so 3 4s are 12 plus 1 is equal to, if you put x is equal to 4 here, so 4 minus 2 is 2 plus b into 4 minus 4 is 0. So the term becomes 0. So therefore, you will get 13 here. A is equal to 13 by 2. Next we will put x minus 2 to 0. You will get x is equal to 2. So put x is equal to 2 in equation 2. What happens now if you put x is equal to 2? 3 2s are 6 plus 1. A you have 2 minus 2 is 0 plus b you have 2 minus 4 is minus 2. So now 7 is equal to minus 2b. So therefore what is b? Minus 7 divided by 2. So substitute the value of a and b in equation 1. So therefore the rational fraction 3x plus 1 by x square minus 6x plus 8 can be written as, the value of a is 13 by 2. So I'll write directly 2 in the denominator. So 2 into x minus 4. And b is minus 7 by 2. So minus 7 divided by 2 into x minus 2. So thus we have resolved the rational function or rational fraction into two simple fractions. So we'll take few more problems of different types or different cases in the next session. So in this session, we have taken the problems on resolving partial fractions of type 1, that is whenever the linear factor is different. And when you have any quadratic equation in the denominator, you just split them as a product of two linear factors so that you can write them as a sum of simple fraction. So next class, we'll take a few more problems for whenever the linear factor is repeating or when you have different linear factor as well as quadratic factor. So when you have a linear factors in the denominator, to find the constants a, b, c, just equate the linear factor to 0 and find the value of x, substitute in the given equation, then write the value of a, b, c, and you will get a rational function as a sum of 3 or 2 simple fractions. In the next session, we'll take few more problems. Until then, keep watching, keep learning and keep exploring. Thank you.